We're going to turn this basic scene with no UI into a true game engine UI. So what is this going to look like? Well, the first thing we're going to do is look at frame buffers. What are frame buffers? Well, we'll get into it in the video, but right now we're drawing our entire scene right to the application window. We're just taking what we make in OpenGL and drawing it to the window, but instead what we're going to do is draw into a frame buffer. Then we can take that frame buffer, and in our UI code, we'll just treat it as an image. And then all we're going to do is in the UI, render that image. So basically what we're doing is going OpenGL, frame buffer, image onto your screen. And if you have no idea what I'm talking about, well, there's a full game engine series I've been building. It's all written in Zig, and I show every episode we're just building on top, making a game engine. But yeah, let's jump into it. So I've written a little bit of code, it's more the kind of glue code or boilerplate that is a little boring. So I just want to go through it quick, and then we'll get to writing the frame buffer, and then we'll get to actually integrating and using the UI library. So first we have render viewport, which just width, height, and gives us an aspect ratio. We're just going to inject that into our context runtime. Then if we come over to window, there's a few things in here. So one, we need window size, cursor kind. So now we can because our UI library allows different cursors as you're kind of dragging. So now we can just grab those cursors from GLFW. And then also some anti-aliasing gets enabled. And then we just create the standard cursors and a few helper functions just to make our life a little bit easier. Same with setting cursors. So just some helper functions that we can use, the UI library can use. And then the last thing, we're going to go into application. So we come down here. So I've kind of restructured this a little bit. So on every frame, we'll gather all the events and then kind of replay them in the frame. But now if we actually come over here and look, our run loop is a lot cleaner. So it's going to be, we start our app, and then as long as we stay open, we begin a frame, we process our events, we update, and we kind of present it to the screen. And actually the clear isn't needed. So we'll go and just present because clear is in there. So yeah, so if we go into some of these like process queued events is now, or I guess begin frame. So we'll just clear the events from the last frame, update the time, handle input. And then what we've done is in our event callback, now we're storing events on. So we come over here, it's an array list of events. And then the callback, we're just pushing it on instead of directly processing that second. It's now going to be processing in batches on the frame. And then render scene. So we're not going to get into this yet because it needs frame buffers, which we're going to be the ones to write. But then again, yeah, present, you just swap buffers and clear. Okay, let's get into frame buffers then. So we'll come over into our graphics OpenGL and call it frame buffer.zig. This is going to look very similar to kind of what we've done in the past, but now it's frame buffers instead of other kinds of buffers. So same, we'll need glad, and we'll kind of enumerate the error types, and let's write it. So const frame buffer is a struct, and it'll have an ID, it'll have color texture, it's going to have a depth stencil, width, and a height. Nice. And then we'll need to initialize it. So function init with a width and a height. So again, as I was saying at the start of the episode, what a frame buffer is essentially right now we're drawing directly to the entire application window, right? So we're telling the OpenGL on the draw calls, just draw to the whole window. But what we want with the UI is we want kind of a place to render, and then just telling the UI, hey, just like put this in this location, which for us, it's going to be the center of the screen, as you saw in the intro. And then we can have UI around it, but we only want to render the center. So I hope that makes sense, but if not, it should make more sense as we write more code. Then I refer self.init, which we will write, and self.resize, which we will also write, and then return self. Okay, let's write that init first. Frame buffer void. So this one, again, kind of just writing functions as ahead of time, but we will need them. We'll destroy our attachments, which is something that's stored, and then delete frame buffers. We'll delete one of them, and self.id, and then self.id equals 0. And then let's just like clean up all the data. Okay, let's write the destroy attachments. Destroy attachments. So then if self.depth stencil does not equal 0, gl delete render buffers, and we'll delete the depth stencil and then set it to 0. Then same with color texture does not equal 0. So if it was present, gl delete textures, and self.color texture equals 0. There you go. We'll also need this. So resize is going to be our big function. We'll write it last, and we'll just write the rest of our kind of helper functions here as we need it. So bind, this is very similar to what we've already seen in like shaders, buffers, all that. We need the bind function, and then gl bind frame buffer, gl frame buffer, and self.id. And then we need to set the viewport to the width and the height of the frame buffer. And then we might need the texture ID, frame buffer, u32, and return self.color texture. And one last one, and that's the bind default. If we just need to kind of render without a frame buffer. So width, just like kind of a direct width and height. So we're just binding it to the 0 spot, and then we'll just kind of grab this viewport call, and instead of self, it'll just be width and height. Perfect. So now let's write the actual big function of resize. So the first thing we'll do is grab our target width and height. Okay, and then now the first kind of initialization that we'll do is like if we haven't actually created the frame buffer, we will create it, generate frame buffers, and we're going to want one of them. And then if self.id equals 0 after that, it's an error. And then we can do self.width equals target width and self.height equals target height. So now we've initialized it properly. And then as we now kind of put on the attachments, if needed, we need to have the frame buffer bounded, but we don't need the viewport. So we're just going to directly take this line and then do an error defer and unbind it if there's any errors that happen. Okay, so now if there's a color texture, or if there's not a color texture, we will generate one. And then if that's 0, we know it failed to create. Frame buffer error texture creation failed. And now we have that, we can bind the texture. So there's just a lot of parameters here. I'm going to paste this one in because it's just going to be very tedious to write. Okay, and this is what that looks like. So first we bind that texture, then we will create a texture image 2D. There's no actual data in it, but then it's just kind of what the frame buffer needs to render. And then we put it that color attachment 0. So just using the same IDs. And now we're going to do the exact same thing with the stencil. And just like before, this time we're using depth stencil. So render buffers, depth stencil, and then the exact same. You bind it, you add the storage. So they're a little different. So this is the actual render buffer, and then the attachment was the image. Okay, and then let's do one kind of error check. Check frame buffer status, and then frame buffer. If it does not equal GL frame buffer complete, then we know we had an error, and then we will return that error, incomplete. And then finally we will unbind. And then finally we will unbind. Sweet, and now we've written our frame buffer. So if we go over to root, we will make sure that gets imported. Let's do here const frame buffer import. It's gonna be graphics OpenGL frame buffer dot frame buffer. And that's also at the bottom. Make sure that's in there. Nice. And now if we head back to our application, we need to go import that. And then one thing I also forgot was frame. Okay, now let's head over to our render scene, which was just wrote, and actually figure out what's going on here. So what we're going to need to do is, if we render scene, basically we're saying if we have a frame buffer present, we want to render to the frame buffer. Otherwise, we use that bind default. So like what we've been doing this whole time. So bind default is the exact same as what we're doing right now. We just set the viewport to width and height. But this bind frame buffer, binding it to 0 is just saying like no frame buffer. So if we don't have a target present, what we're gonna do is we're just gonna, like we said, render to the whole screen, the whole application window, and don't render to a frame buffer. But if there is one being passed in, then we want to render to that frame buffer, which is the case of our UI. So with all that said, let's hop over to our editor UI. The very first thing we actually need to do is grab our UI package. And I haven't talked very much about it, but it's the one I've written just for this series and like for my game engine. Is if you've been following along the whole time, you should be able to use this with no problems. It was made without taking an actually true struct from Zephyr runtime. So if you have the same structure as we've been writing, it should just work for you. But if you've made some different choices, you might have to tweak things a bit. But yeah, so let's first get that ready. Okay, and if we come into the build.zig.on, we can see it's in here, zGUI, that's perfect. And then I just went ahead and added just a few lines. So again, you add dependency, create a module, then you add that to the imports. Let's get into it. So just to kind of help us out, there's two things that we should have been doing the whole time, but we haven't been. So one is going to be GL depth test. We should have been enabling that from the start. And then this will eventually go away when we get to things like ECS and proper kind of camera management. But for now, we're just going to make sure our editor camera stays the proper aspect ratio. Again, there's definitely better ways to do this, but just making it a little bit easier for us. And one other thing I did is I just added a font for us to use in our editor. If you go to the GitHub, you'll be able to find it. Right, and very soon we're going to be hooking up the actual main.zig here. There'll be quite a few changes in there, but we need to kind of write our base editor UI file. So I'm going to create a new folder called UI and just make editor UI.zig. We'll need some imports and zGUI. And all right, so let's start writing it. So these are going to be the 4 files that we actually make, which we will go through all of them, but we haven't written any of it yet. But let's just get a few constants going. And yeah, so I'm just going to speed up kind of writing a bit of this code, and then we'll see what it looks like. Okay, so now we have a little bit of code written. So I just want to go over where we're at so far. So resize handle thickness, I think that's pretty self-explanatory. We'll be able to resize the panels, and this just controls that thickness. And then the side width, so how thick are our left and right panels, how wide is the center, and then the bottom height, so the bottom panel's height, and then the main height of the actual engine itself. And then we're going into the nodes, so we're going to have the viewport, which is the main part, the host, which is our root, and then all our panels. Then we also need this for docking, because this library that we're using does have docking, and I just want to use it right away. So there's going to be just extra code around that, but I think it'll be worth it. One thing I just want to call out here is we have a predefined theme that we're going to use, and just the default dark theme, but yeah, just want to call that out. And then UI doc space, init allocator. So yeah, I'm going to keep trucking along. Okay, so now kind of written a bit more. So what we're going to have is our init, and then we'll create our nodes, which will be our editor tree, and then create our doc tree, which will be the refs. Again, as we write those actual functions, I think that'll make more sense. Then we need a doc space. So we're creating a doc space through the UI library. And then this is where that handle thickness comes in. And then every tab height we'll be able to control. But yeah, I'm just putting to 30. And then viewport is again something we haven't written yet, but that'll be the main area. And when I say this is where it kind of all comes together for the frame buffers, because when we say set texture, we're actually setting a frame buffer, which like I said, our UI library just treats it as a texture and then puts a texture on the screen. But in reality, our render is writing to a frame buffer, and that frame buffer gets written or like rendered as a texture. And then we'll also do just helper function for viewport rect. And now let's go over our actual doc tree. So like I said, there's docking. So we're going to have all these different panels around. So we need to create them. So scene, viewport, inspector, console. And we're doing create window because you can drag them out and they'll be their own windows too. So yeah, just so that makes sense. And then all this is just kind of the math and moving around to make it like right, bottom, left, and then getting that window in the end. And then something very similar, but now we're getting our nodes. So first, so we'll have our builds functions in each of these. So again, these are the files we haven't written yet. And then it'll just create the different panels and we get all the nodes for each panel. Now we're going to go one by one, going over each of those UI elements that we were talking about. So this is going to be the scene, and that's the left side panel. So we're going to have builds. We see we're creating a column. Again, it's a panel, so it's vertical panel. And then we just put in a bunch of information about it. We'll have a header. And then for now, we're just putting text. Same with all these. We're not actually filling in what they're going to do and look like. We're just kind of adding text of what it explains, except for the viewport, obviously. Okay, and here's that viewport. So again, we're rendering it as an image, like I said a few times here, and then we can also set that image. But it's going to create an image, and then a frame buffer will be bound to it, and it'll style it like that. And then again, any sort of styling things we want, we can just throw in here. All right, and second last one is our inspector. So this is kind of going to be the right side panel. So again, it's just another column, we'll have a header, and then we just have text filling the space. Okay, and our last one is the console. So this is the bottom console, still another column, but it's just going to be less tall and more and wider, takes up more space. And again, just text filling it. All right, so now if we head over to main, you can see, start to import things, but we want to edit our UI, and now let's hook this all up together. So we're going to do the same push scene, but now it's going to be, now we kind of take manual control because we kind of need to inject things into the UI library, and it's just, when we're actually running a game itself, this is perfectly what it was before, perfectly okay for running an actual game. But since we need all this UI stuff, we're going to just need some more. So we'll actually get our UI render UI, and we're going to just use OpenGL render because that's what's there for now. And now we can get that proc address. So again, this is one of those functions that we just added in today, the helper, and it just gives control into the UI library and init. Now we can create our font atlas because we need fonts. Try, and then it'll be UI font atlas.init. It's going to take our allocator, and then we'll just do that. And quick embed file, assets, fonts, and then the font we want. That'll be 1024 by 1024. And then defer dnit. And then we just need to make sure that that's synced properly. Again, just passing things off to the UIs. And now we need a UI state because it obviously need to be stateful a bit. UI.init and an allocator, and then dnit as always. And now we need the frame buffer, the viewport. So this is where everything we've done today truly comes together. So we're going to create a frame buffer, and let's just call it 1.1 for now. It gets resized. Viewport.dnit. Nice. And then we need a UI backend. So we're actually going to use Zephyr runtime, like I said, and it's not fully typed, so you should be able to just use it if, again, you followed along with the series so far. And then the last one we need for our loop is a scene capture. And this allows us to actually kind of capture that input and use it properly in our UI and going between the app and the UI input. So this is going to look a lot like our run function, like we have an application. Events equals app.begin frame. And then UI frame equals try, UI backend, that also needs begin frame. And then it can take those events. And then try UI state, also begin frame. Frame to begin frame. Oh, one thing somehow managed to miss doing is under UI state, we also need to create our editor. Try edit UI, so this is what we were just in, init.gpa, and then needs that UI state. And then, as always, editor dnit. Now coming back down, we can use it and create our doc space. Doc space, the state, and then the UI frame and window size. And now we can do set cursor. Again, this is one of the ones we just did. And then UI state dot requested cursor. Okay, and then we're getting close. So then set viewport texture, UI state, and then viewport dot texture ID. So again, viewport is that frame buffer we created. UI state dot set text raster scale, UI frame. Again, you don't really have to worry about this. And then we end the frame. And then I'm just going to put in the last few here. So we get the rect, render size, we resize, process events, pump assets, resync, and then end things. And just finding some mistakes here. This was meant to say viewport. And one other small place we missed is UI state dot set font atlas, which we need to do. And it'll be that font atlas. Okay, now let's see if we run it, what happens. There we go. And we can see it's all here. So I know this was a lot, but I mean, if you look around, we still have our same thing. And then also you can kind of drag it. You can move these around. You can see how it all interacts. And yeah, so this is all very cool. So you can move things around and play around with it. Make the UI yours. We will obviously be doing lots with it, but yeah, this was a very big episode. So if you stuck around this long, great job. I know it was a lot, but hopefully this is all worth it because now we have a full UI and we can truly make an editor, right? And I hope you enjoyed the video. Obviously this is a little bit of a different background than in the past. I'm trying to change things up, edit it a little bit differently, trying to make it still trying to be as informative and actually writing the code, but then also try and make it a little bit more entertaining, you know, want people to watch the videos and learn something. So I'm trying to maybe change how we're doing things a little bit, and we'll see. I'm just still playing around with it, still early making YouTube videos, so I'm just trying to see what works. Yeah, let me know if you like this. If you like the format, kind of how this video went, please leave a comment, tell me what you think. And if you didn't like it, if you liked how we did things before, also please let me know. Your comments, all the feedback really helps me know what you guys want, and that's what the videos I want to make. I want to make videos that you guys are enjoying. And again, if you like this video, leave a comment, like, subscribe, all those things really help the channel. But yeah, that's it for today, so have a great day.